This time what we're going to do is we're going to find the area of a parallelogram determined by a couple of vectors, and what we're given is information which will allow us to compute that area of the parallelogram. So there's a lot of moving parts in this question, but first of all what it does give us is it gives us that the norm of u, or the length of one of the vectors, is a 1, so he's a unit vector in fact, turns out. And then it also gives us that the norm of v is 2. It also gives us the angle between the two vectors, which is, I'm just going to call it theta, which is 30 degrees or pi over 6 radians. Then what we're going to do is we also need to know what that means, the parallelogram determined by the vector 3u and u minus v, 3u plus v and u minus v. So let's draw this picture. Basically, if you're doing the linear algebra, whenever possible, and it's quite often, you should be drawing yourself a picture. It talked about the area of a parallelogram. It doesn't have to be to scale. It doesn't have to worry about what the coordinates of the vectors are. They didn't even give us this. What I'm going to do in my mind, just so I can picture this, is I'm going to create this vector 3u plus v, and I'm going to create this vector, say, u minus v, whatever they look like. Suppose they look like that. I put them tip to tail. They now determine the area of a parallelogram. That's what we're talking about in the problem now. So now that I've drawn the picture, it will make a whole lot more sense to try and build from this information how to find the area A of this parallelogram, which is what we're going to do. Basically, I want to create the area of the parallelogram between 3u plus v and u minus v. What the area of that parallelogram is determined by any two vectors is going to be the area of that parallelogram is exactly the norm of the cross product of the two vectors, which are the sides of that parallelogram. So in our case, that's going to be 3u plus v cross product with the other vector, which they've given us to be u minus v. So we want to find a length of this horrible cross product. And then, so first what we're going to do is compute that cross product and expand that using the cross product rules, and then I'll apply the norm at the end to find what the area of the parallelogram is. Again, without all the machinery, what I'm going to do is chop it into pieces first, and then we'll put it in the pot and start stirring. So I have 3u plus v cross product with u minus v. That's what I have, and I have to simplify this, so what I'm going to use is the rules. First, what I'm going to do is I'm going to take this entire vector. You can call it W if you want, or something else, but we're going to distribute it onto both of these. That's our first move. So doing that move, technically speaking, I get 3u plus v cross product with u, and then plus 3u plus v cross product negative v. Then what I'm going to do is take the same move and do it twice. I'm going to distribute u back onto these two components and negative v onto these two components using the rules one at a time. Technically what I now get is this will be 3u cross product with u, then plus v cross product with u from the first two. Then from here I'm going to get plus 3u cross product negative v and plus v cross product negative v. Then what I'm going to do is use the other properties of cross product, which says I can pull all the numbers to the front of cross product. So wherever I have these in any spot, either spot, all the numbers can go to the front, is what that's saying. So what I'm going to deal with is this and this and this and this is what I'm dealing with. I'm going to move them all to the front. Now this says this is equal to 3u cross u plus v cross u plus minus 3u cross v, and then minus v cross v. Now, using the last property, property 4, usually if they're listed, the cross product of any vector with itself is the 0 vector. So this is 0, and v cross v is also 0, so they disappear. The last move I'm going to do also is in this step, I'm going to use the anti-commutative property of u cross v. U doesn't have a vector there. That is correct. I'm going to interchange those two guys. It's not commutative, it's anti-commutative, which means I get a negative when I introduce this. So I get negative u cross v minus 3 u cross v. And then I can add these things, I get negative 4 u cross v. So all of that work was using the properties to simplify what the expression of the vector that I'm going to have. Now that I have that, I can find the area of the parallelogram determined by these two things. So now I have that. So let's put that in there. Therefore, the norm of 3u plus v cross u minus v is given by the norm of 3u cross v, plus v cross u minus v is equal to, now we've computed this, is equal to the norm of negative 4 u cross v. Now what I'm going to do is use properties of the norm, and I'm going to take the negative 4 out. So this is equal to the absolute value of negative 4 times the norm of u cross v, which is equal to absolute value of negative 4 is negative 4, which is times u cross v, which is equal to 4 the norm of u cross v. Now that I've simplified and used norm properties, now I'm finally going to use the fact that we have a link between the norm of u cross v and the norm of the two original vectors. The norm of a cross product is equal to the norm of u times the norm of v times sine of the angle between them. That's why they gave us theta is pi over 3 or pi over 6, or 30 degrees at the beginning. That's what I need that piece of information for. So finally now in this step, the 4 has nothing to do with it, but the norm of u cross v is the norm of u times the norm of v times sine of 30 degrees, or pi over 6 radians. That's where we use that finally. And what does that become? That becomes 4 times the norm of u was 1, the norm of v was 2, and sine of 30 degrees is 1/2. That's correct. So those cancel. 2 and 1/2 cancel, and I get 4. The area of the parallelogram determined by u and minus v and 3u plus v is going to be this guy. The area of that is the magnitude of 3u cross v plus, I really want that to be a cross for some reason, cross u minus v, which we saw was 4 times the magnitude of u cross v, which was equal to 4 times the magnitude of u times the magnitude of v times sine of the angle between them, which happened to be 30 degrees. Once I do that, I put all the information in. This is 4 times 1 times 2 times 1/2, cancel, cancel, which is 4. This is the area of the parallelogram.